Platform architecture in Eclipse. Here you can see a platform architecture. As a separate view. The Eclipse platform is structured around the concept of plugins. Plugins are structured bundles of code or data that contribute functionality to the system. Functionality can be contributed in the form of code libraries, Java classes with APIs, public APIs, platform extensions, or even documentations. Plugins can define extension point, well-defined places where other plugins can add functionality. Each subsystem in the system is itself structured as a set of plugins that implement some key function. Some plugins add visible features to the platform using an extension model. Others supply class libraries that can be used to implement system extensions. The Eclipse SDK includes the basic platform plus two major tools that are useful for plugin development. The Java development tools, JDT, implement a full-featured Java development environment. The plugin developer environment, PDE, adds the specialized tools that streamline the development of plugins and extensions. These tools not only serve a useful purpose but also provide a great example of new tools can be added to the platform by building plugins that extend the system. With runtime core here, the platform runtime core implements the runtime engine that starts the platform base and dynamically discovers and runs plugins. A plugin is a structured component that describes itself to the system using an OSGI manifest.mf file, and a plugin manifest plugin.xml file. Platform maintains a registry of installed plugins and functionality they provide. The general goal of runtime is that the end user should not pay a memory or performance penalty for plugins that are installed but not used. A plugin can be installed and added to the registry, but the plugin will not be activated unless a function provided by the plugin has been requested according to the user's activity. The platform runtime is implemented using OSG iServices model. While implementation details of the runtime may not be important to many application developers, those already familiar with OSGI will recognize that an Eclipse plugin is in effect an OSGI bundle. The best way to get a feel for the runtime system is to build a plugin. Resource management. The resource management plugin defines common resource model for managing the artifact of tool plugins. Plugins can create and modify projects, folders, files for organizing and storing development artifacts on disk. Workbench UI. The Workbench UI plugin implements the Workbench UI and defines a number of extension points that allow other plugins to contribute menu and toolbar actions, drag and drop operations, dialogues, wizards, and custom views and editors. Additional UI plugins define frameworks that are generally useful for the user interface development. These frameworks are used to develop the workbench itself. Using the frameworks not only eases the development of a plugin user interface but ensures that the plugin have a common look and feel and a consistent level of workbench integration. The standard widget toolkit SWT is a low-level operating system independent toolkit that supports platform integration and portable API. The JFace UI framework provides a higher level of application construct for supporting dialogues, wizard, actions, user preferences, and widget management. Team support. The team plugins allow other plugins to define and register implementation for team programming, repository access, and versioning. Debug support. The debug plugins allow other plugins to implement language-specific program launchers and debuggers. Help system. The help plugin implements the platform optimized help web server and document integration facility. It defines extension points that plugins can use to contribute help or other plugins documentation as browsable books. The documentation web server includes special facilities to allow plugins to reference file by using logical plugin-based URLs instead of file system URLs. Additional features are provided for integrating help topics in product level documentation configuration. Java Development Tools JDT. The Java Development Tools JDT plugins extends the platform workbench by providing specialized features for editing, viewing, compiling, debugging, and running Java code. The JDT is installed as a set of plugins that are included in the SDK. The Java Development User Guide describes how to use the Java tools. The JDT plugin developer guide in the documentation describes the structure of API of the JDT. Plugin development environment. The plugin development environment PDE supplies tools that automate the creation, manipulation, debugging, and deploying of plugins. The PD is installed as a set of plugins that are included in the SDK. Here you can see the Java development tooling JTD and plugin developer environment PDE and Eclipse platform are inside Eclipse SDK. Java development tooling JDT and plugin developer environment PDE and new tools are connected to Eclipse platform. Workbench, help, workspace, team, and platform runtime are inside Eclipse platform. SWT and JFace are inside Workbench. Now this is the end of my presentation. Thank you very much for watching it.